Hi, I'm going to go over some of the things that I went over in class. Specifically, I want to review, or at least record so you can look at this again if you need to, how to answer questions like what is the probability of an event occurring that's between two numbers. So in this case, it's what's the probability of sales revenue between 340 and 440. And what we're going to do is look at this column of numbers, and what we want to do is find out what's the probability that we're going to get a value that's, say, between some number, some range. And there's a bunch of numbers here. So how many do I have? I've got about 7,100 records. This data corresponds to all the weekly sales data from all the games we played in ERP Sim for the water distribution game. So here's the product, and here's the price that was charged for that product by this team on that day in that area. In this case, all the areas have the same price. Sold that many units, and it's that value. So 29 times 14.99 is 434.71 euros. Now, to answer this question, I want to get a frequency distribution of all these values. So how many times does a value between, say, 400 and 420 occur? How many times does a value or total sales revenue between 420 and 440 occur? So it's things like that. That's what I want to get, that distribution. To do that, it'd be nice if I knew the minimum and the maximum, and then I'm going to use that as my upper and lower limits and find the counts. I'm going to divvy up those upper and lower limits into ranges of, say, 10 or 20 or 40, and then find out how many are in those ranges. So I might say, what's the min of this, and I'll hold down shift and end and down arrow, and it'll go to all those. So 22.99 was the min, and the max enter, that's the max. So pretty big revenue there for a weekly sales revenue. And then we might say, how many divisions do we want? How many ways do we want to divvy that up between 22.99 and 17.83? Let's say I want 30 divisions. Oops. So that'll be how many divisions I want, and that's 30. So basically, I want to find out what interval I need. And so that's all I'm doing here. It's kind of a long-winded way to do this, but it gives me an idea of the step size is what I'm getting at. Oh, I thought I had a parent. There we go. So I need about 60 divisions to go of width 30. Let's say divisions of 40. So I'll need about, that'll take about 44. And what that means is, let's say I start at 20, and I go, next I'm going to go up to 60, so that's a step of 40. And if I do this down, I'll need about 44 of these to get to 1783. So we're going down, so there's 1820. So that's pretty close. That just gives me an idea. So next I want to fit this data here, all this data here, into these bins. So these are my bins. This is what Excel calls them, or bins. And the function that we're going to use is the frequency function. It's an array function. So it's equal to frequency, and I want to put the data in this is all the data, control end down arrow, comma, I have to go back to the top, and these are the bins that I want to put that data in. So I'll select my bins. I could have done that shift down also. And now I have to do control shift enter. That's how you enter an array formula. Control shift enter. So this is what the data looks like, and we should plot this, and then you can get a better idea. So this would be like count if I wanted to plot this. So if I selected this scatter chart, try it again. I'm not used to this computer, as you can maybe tell. So there. This is the frequency distribution of all these values, which are my total sales revenue. And this is what the probability distribution looks like also. So how do I answer this question about what's the probability of sales revenue between two numbers? Scooch this down here. Well, let's say it's between, I say 340 and 440. I don't have 440 here. So let's say 460. I want the probability between of these numbers occurring. Well, to get a probability, I have to associate these with percentages. Oops. So what I want to do is count up the total, get the total count here. So there's my total count. It's 7107. That's how many records we had, right? And then this will be my percentages. And this percentage is this divided by that number there. And then I need to make it an absolute reference. And if I double click on this, it'll go all the way down. May as well make those percentages and maybe give them a little bit of precision there. So now I'm getting closer to answering this question. What's the probability that I'll have revenue between these two numbers? Well, it's the sum of those. That's about 30%. So that is close to answering that question. An easier way, or one that's getting closer to what we want, is a cumulative probability. And this is going to be, start out as that one, and then I'm going to keep adding the next one to the previous, or the current to the previous. So I better end with 100% at the end. Good. So this is 100%. So now if I wanted to say what's the probability of getting between 500, here's the 500, it's the revenue, between 500 and 420, well, I would subtract these two. I would subtract 56 minus 44, and that would be about 12%. So that's 12% is the probability of getting between these two revenues. Now if we plot this, you'll see that it has a nice look to it. This is a cumulative probability distribution. It has sort of an S-type shape to it. And we could fit a curve to this, and it would be a pretty nice curve. It would fit pretty well. And then we could answer questions that are more detailed, like what's the probabilities between 311 and 413. Any number, it doesn't have to be in these bins, it could be anywhere in between. And we do that by using this a regression that fits that curve. Well, a regression to fit that curve, I could either add a trend line, which I don't really want to do, but that trend line doesn't fit very well. Logarithmic, maybe, sort of, polynomial. Well, that's getting pretty close. Polynomial of degree 3, that's pretty close too. I think that's degree 3. It's hard to read on the screen. So that's a 98% r squared. Degree 2 is a 98% r squared. So this is the equation for a quadratic to fit that curve. Now, a quadratic is not going to be that good, but it's we could try it. What I would recommend is a cubic, because this looks like a cubic. This S is what a cubic looks like, and we can show you something with that too. So to make a cubic, I want to use this linest function, which is linear estimation, to calculate a polynomial. And so I'm going to select some data here. Let's see, there's the cubic, squared, x, constant, and some extra data. So I enter all those cells, or select all those cells, and I do linear estimation, and my y's are what I'm trying to predict. So I'm trying to predict this probability. So these are the things that I'm trying to predict, my y's. And my x's are these revenues, these total sales revenues. So we want B to be calculated normally, and comma, and we'll return some extra statistics. So I think I did that right. So I have to do Control-Shift-Enter, and so I forgot I needed to put this quadratic. So 1, 2. That means use up to 2 exponents. So there's the equation. So this is the x squared coefficient. This is the x coefficient. That is, and that's the constant. There's the r squared. There's the f value. So that's a really high f value. So that means it's a pretty good fit. So what I can do is I can say lower limit, that's going to be a value. So let's say 100. That's a sales revenue. And upper, let's say that's 502, just some number. And this will be the probability. So this, I think I'll scooch that down. This will be the probability. Prob. And this is going to be this times, I think I'll do it this way. There's the coefficient times this squared plus this coefficient times this plus the constant. And I could put these values here. I could stick them in place so that I can drag this down to the next one. So that's a probability. That's a probability. Did I do that right? Yeah, it looks right. So these are percentages. 500, 100, about 0, 500, about 50, this says 56, this says 51. So it's kind of close, and the difference is this minus this. So that's the probability that's between 502 and 100. Let's change this to 420, and this 500. So 500 it says is 56.5, and 420 is 44, and the difference there is about 12. So this doesn't seem like all that good of a fit to me, but it's an approach. Cubic probably would have been better. So this is a way to use a regression to estimate. Say this is 401, and 892. For some reason we have those. Well, we estimate about 44% of that occurring. Or you could go down here and estimate it via these tables. That's the general idea. Trying to fit a curve to existing data to estimate the probability of a future occurrence.